Yeah, in this problem, it is given that a block of mass 0.2 kg is suspended with the help of a string, and another block of mass 0.3 kg is suspended with the help of another string, and it is connected to the 0.2 kg. Then the question is, what are the tensions in the two strings? T1 equal to how much? T2 equal to how much? That is the question. As we discussed earlier, T1 means tension in this string. On this string, these two blocks are acting, and weight of these two blocks act on this string 1. So tension 1 is equal to, these two blocks act as a single block, that's why it is mg, 0.2 plus 0.3 into g, that's all. It's equal to 0.5 g. Next, T2 means for T2 this acts as roof. So we need not to consider this 0.2 mass as a mass. We can consider this as a roof, and T2 means only the 0.3 kg mass is acting on this. That's why T2 is equal to 0.3 into g. That's all. These are T2. Yeah. See, in this problem, it is given that two blocks of equal masses, m and m, are connected with the help of a string, and one of the blocks is pulled with a constant force F. Now the question is, what is the tension in this string? T is equal to how much? So tension means a force applied on this block. So tension is equal to force acting on the block is equal to mass into its acceleration. So our target is to find this acceleration. So as these two blocks are connected with a string, the two blocks move together with a constant acceleration a because of the application of force F. So F is equal to, for this F, these two blocks act as a single block, that's why m plus m into, these two blocks move with a constant acceleration, a, that's why a is equal to how much? F by 2m. Now if I put this a here, now our tension T is equal to m into F by 2m, mm gets cancelled, that's equal to F by 2. So these are tension in the string. That's all. Yeah. It is very interesting problem. See this. It is given that there are two blocks A and B. Mass of A is MA and mass of B is MB. These two blocks are in contact with each other and they are kept on a smooth horizontal surface. An experimenter means a person is applying some force on A. We don't know this force actually, but because of this application of force, capital F's force is acting on B block. Some force is acting on A by the external agent or a person like me. If I am applying some force on this, because of that, capital F force is acting on B block. Then what is the force applied by the experimenter? Fa is equal to how much? Earlier we have done problems like if Fa is given, we found F, but in this problem he gave F means contact force. He is asking us to find the main force, external force. Simple. So let us imagine that the unknown force is Fa for a while. Because of this Fa, these two blocks are moving together. They move with a constant acceleration A. So for this external force, these two blocks are nothing but a single force. That's why Fa is equal to mass of A plus mass of B into acceleration of the system. Keep this as equation number 1. Now come to this. If you imagine, ignore this A for a while, only B block is left with. On this B block, capital F force is acting. Because of this capital F force, this block is moving with an acceleration A. So if I take B block, capital F is equal to mass of B into acceleration. So from this A is equal to how much? F by M times B. So here the only unknown is A. To find Fa, we need A only. We got A here. If I put this A here, what I get? Fa is equal to Ma plus Mb into F by Mb. So these are our external force. When contact force is given, this is how we can find external force. If external force is given, we can find this contact force by sending these masses to the left direction. That's all. Over. See this problem. There are 3 blocks, each of mass 3 kg, 2 kg and 1 kg are kept on a smooth horizontal surface. An external force of 12 newtons acting on this 3 kg horizontally. Now the question is, what is the force acting on this 2 kg? And what is the force acting on 1 kg? That is the question. So in such problems, what you have to do? First of all, we have to find the acceleration of the system. As a whole, the system is moving with uniform acceleration A. So for this 12 newtons, these 3 blocks act as a single block. That's why this is like this: 12 newtons, 3 plus 2 plus 1, 6 kg. Means on the 6 kg, 12 newtons of force is acting. That's why acceleration of the system is equal to F by m. That is equal to F means 12 by 6. That is equal to 2 meter per second square. Means the system or individual blocks are moving with an acceleration of 2 meter per second square. Now if I want to find this force acting on 2 kg F1, I need to ignore this 3 kg block. If I ignore this 3 kg block and also if I ignore this 12 newtons, F1 force is acting on these 2 blocks. So for F1 force, these 2 blocks act as a single block of mass 3 kg. So F1 is equal to how much? Mass into acceleration. Mass means 3 into acceleration equal to how much? 2. That is equal to 6 newtons. So this is 6 newtons acting here. Because of the 6 newtons, these 2 blocks are moving. Okay. So force acting on this 2 kg is nothing but 6 newtons. Now if you want to find the force acting on 1 kg, what I have to do? F2 is equal to mass of this block into acceleration of this block. Mass of this block is 1 kg and acceleration of the block means the acceleration of the system 2 meter per second square is equal to 2. So F2 equal to 2 newtons means on this block 2 newtons force is acting. On this block 6 newtons of force is acting. On this block 12 newtons of force is acting. Is it clear? So I hope you understood this problem. If you don't understand this problem means you didn't listen my concept of contact forces based on previous lectures. So go through my previous lectures and then you can easily solve this problem. Okay, don't solve problems without listening my concept. Look at this problem. In this problem it is given that 3 blocks is of mass 4 kg, 2 kg and 1 kg are kept on a smooth horizontal surface, and the blocks are connected by a light inextensible string. Light means the mass of the strings are not to be considered. Now if a force of 14 newtons is acting on 1 kg block, the question is, what is the acceleration of the system, what is the acceleration of individual blocks, and what are the tensions in between the strings? Okay. Now as a whole, the system is moving with uniform acceleration as everything is attached with the inextensible strings. For this 14 newtons, these 3 blocks act as a single block of mass 4 plus 2 plus 1, 4 plus 2, 6 plus 1, 7. So this act as a 7 kg big block. That's why F is equal to mass of this system into acceleration of the system, 4 plus 2 plus 1 into acceleration. That's why acceleration is equal to F means 14 by this is 7, that is equal to 2 meter per second square. Means this system moves with an acceleration of 2 meter per second square. Means this moves with 2 meter per second square, this moves with 2 meter per second square, this also moves with 2 meter per second square. Next question is, what is the tension here? What is the tension here? So when you are finding the tension in this string, you can ignore this mass. Okay, if you can ignore this mass, ignore this for a while. So because of this T1, these 2 blocks are moving. So T1, for this T1, these 2 blocks act as a single block of mass 4 plus 2, 6. That's why T1 is equal to mass of the system into acceleration of the system. So 4 plus 2 into, what is the acceleration of the system? 2. That's why it is 4 plus 2, 6, 6 into 2, 12 newtons. So here the tension is 12 newtons. Is it clear? Now come to this T2. So as to find the T2, we need to ignore these 2 masses and only one mass, only one tension we have to find. T2 is equal to mass of the system into the acceleration of the system. Mass means 4 into acceleration is 2. That's 8 newtons. So here the tension is 8 newtons. Here the tension is 12 newtons. Here the tension is 14 newtons. Is it clear? Good. Note down. This is very interesting. There are 3 blocks, each of mass 1 kg, 4 kg and 2 kg are kept on a smooth horizontal surface. 2 forces are acting here in opposite directions. So one is 120 newtons and the one is 50 newtons. Now the question is, what is the acceleration of the system? So for this 2 forces, these 3 blocks act as a single block of mass 1 plus 4 5 plus 2 7. So it is nothing but these 3 blocks can be written as a single block of mass 7 kg, and in this direction 120 newtons of force acting, in this direction 15 newtons of force acting. So as the 2 forces are equal, as the 2 forces are in opposite directions, the forces, the resultant force is given by 120 minus 50, that is equal to 70. So on this 7 kg block, 70 newtons of force is acting towards the right in this direction. This 50 will be cancelled. 120 minus 50 is equal to 70. So because of this 70, this block is moving. So F is equal to M into A. So the net force equal to 70 is equal to M means 7 into A. This implies A is equal to how much? 70 by 7, that is equal to 10 meter per second square. Means this system is moving in this direction with an acceleration of 10 meter per second square. Means this moves with 10 meter per second square, this moves with 10 meter per second square, this also moves with the 10 meter per second square. This is our first question. Now let us look at the next question, that is the normal force between 1 kg and 4 kg. Means here, what is the force acting here between 1 kg and 4 kg? Means what is the force acting here? So then also in this case we need to ignore this 1 kg, 120 newtons, this is 50 newtons, means the net force is the net force is 70 is acting. So the net force is 70 newtons acting in this direction. We have to find the force acting on this 4 kg, means this is small f. So when you want to find the force acting on this 4 kg, you can ignore this block. So then what happens? This is like this. Some force, small f is acting, this 4 kg, this 2 kg. Because of this small 4 kg, these 2 blocks move as a single block. That's why F is equal to M into A. That's why it is 4 plus 2 into acceleration of the system, means how much? 10. So small f equal to how much? 4 plus 2, 6 into 10, 60 newtons. So the force acting on this 4 kg is 60 newtons. The next question is, what is the force acting on this 2 kg? 2 kg. In that case, what we have to do? We have to ignore this also. So only 2 kg block is left with, and some force F dash is acting on this. So F dash equal to mass into acceleration. So F dash equal to mass means 2 only, because when you want to find the force acting on this, we need to ignore these 2 masses. And what is the acceleration? 10. That is equal to 20 newtons. So here on this 2 kg block, 20 newtons of force acts. Is it clear? In this problem, 2 blocks, each of mass 4 kg and 2 kg are attached with the help of a string, and this 4 kg block is pulled with a force of 120 newtons in the upward direction. Then the question is, what is the acceleration of the system? Now let us see the free body diagram. For this 120 newtons, this 4 kg plus 2 kg act as a single block. So for this 120 newtons, this act as a single block of mass 6 kg. Now what are the force acting on this 6 kg? One is upward force 120 newtons and its weight 6g, means 6 into 10, that is equal to 60 newtons is acting in the downward direction. As these two forces are in the opposite directions, what is the net force? 120 minus 60, that is equal to 16 newtons. So 16 newtons of net force is acting on the 6 kg. That's why acceleration is equal to F by m, that is equal to F means 60 by net force, net mass is 6, that is equal to 10 meter per second square. So each block moves upwards with an acceleration of 10 meter per second square. Now the next question is, what is the tension in the string? So here what is the tension? It's equal to how much? So tension means the force acting on the string. So if this is T, now when you are finding this T, we need to ignore this one. So if I take the free body diagram, this is our 2 kg and the T is acting in this direction. What is acting in the downward direction? For this, when you are considering this, its weight is acting in the downward direction. Then you need not consider this 4. That's why 2g is acting in the downward direction. So T minus 2g is our net force, which is equal to m into a. M means 2 into a means a. So our T equal to how much? 2g plus 2a, that is equal to 2 into 10 plus 2 into a means how much? 10. That's why this is 20 plus 20 is equal to 40 newtons is the tension acting in between, acting on the string. Is it clear? That's all.